This is Lesson 89, Saxon Algebra 1 3rd edition. This lesson is on value problems. So remember that when we read word problems, we look for any word statements about quantities that may be equal, because you have to have something equal to have an equation. Next, we change each of these word statements into an equation that makes the same statement of equality. To do that, we use as many variables as we need. When we have written as many independent equations, because in a system of equations and these word problems, you're probably going to need to have two and either use substitution or elimination. So when we have it written as many independent equations as we have variables, we solve by either substitution or elimination. Let's look at this first example. Airline fares for flights from Tifton to Adele are $30 for first class and $25 for tourist class. If a flight had 52 passengers who paid a total of $1,360, how many first class passengers were on the trip? Alright, so we have, first we're going to have the number of first class plus the number of tourist equals 52. Okay, there were 52 passengers. That's how we get that. Then we are going to attach value in our other equation. 30 times NF plus 25 times the number of tourists equals a total of 1,360. Now, just like in the lesson we just did a couple days ago, we're going to have to go in and rearrange this a little bit so that we have something to substitute in. So I'm going to subtract NT on both sides, and I have NF equals 52 minus NT. I can substitute that in right here for this. I'm going to substitute this in. Then I'm simply going to solve my equation. I'm going to work it out. And 30 times 52 is 1,560. 30 times negative NT is negative 30 NT. Plus 25 NT equals 1,360. Well, I'm going to combine my like terms. So negative 30 positive 25 gives me negative 5 NT. Now I'm going to subtract my 1,560 on both sides, and I get negative 5 NT equals negative 200. Divide both sides by negative 5, and I will find that the number of tourists were 40. Now, if the number of first class plus the number of tourists were 52, and I now know how many tourists there were, 40, then I can solve for how many first class, and that would be 12. In example 2, Wataksha's dress shop sold less expensive dresses for $20 each and more expensive ones for $45 each. The shop took in $1,375 and sold 20 more of the less expensive dresses than the more expensive dresses. How many of each kind did they sell? Now, in things like this, you're going to have to be really careful, because I'm going to look here and I'm going to see NL does not equal NM. NL for the number of less expensive and more expensive. That's how I chose those variables. They don't equal each other. It wasn't the same. The only way I can get this to equal this is if I add 20 to it, because they sold 20 more of these than they did these. So for it to equal, I have to add 20 to this, and then it will balance. It'll be equal. Now that I've done that, I've got this set up. Don't have to rearrange anything, because I already have NL and a value for NL. Then I'm going to attach the value here, 20 times the price of the number of less expensive, plus 45 times the number of more expensive equals a value of 1,375. Now I simply substitute in what I've got here, this value, right there. Do the math, distribute, combine my like terms, 20 plus 45, subtract 400 from both sides. I get 65 NM equals 975. Divide both sides by 65 and I find out that the number of more expensive dresses was 15. Coming back here, I know that the number of less expensive equals number of more expensive plus 20. If the number of more expensive was 15 and I add 20 to it, then the number of less expensive dresses was 35. Okay, our practice problem A. Tickets for good seats cost $8 and tickets for the other seats cost $3. If 18 tickets were sold for a total of $119, how many tickets for good seats were sold? So I need two different equations. So I've got the number of good plus the number of others equals 18. Total of 18 tickets sold. But here I'm going to have to subtract the number of others from both sides because I'm looking for the number of good. Now I know that the number of good equals 18 minus the number of other. And here I've got a value, $8 times the number of good plus $3 times the number of others equals a total dollar amount of $119. Alright, now I'm going to substitute in right here 18 minus NO, and then I'm going to fill out everything else. So let's do our distributive property. 8 times 18 is 144. 8 times negative NO is negative 8 NO plus 3 NO equals 119. Now we've got like terms here that we can combine. So negative 8 and positive 3. We have 144 minus 5 NO equals 119. Now we're going to subtract 144 from both sides. And we get negative 25. I'm sorry. Negative 5n equals negative 25. If we divide by 5 on both sides, we know that n is equal to 5. I'm sorry, NO. NO equals 5. If NG plus NO equals 18, NG plus 5 equals 18. Subtract 5 from both sides. We find that NG is equal to 13. So 13 good tickets and 5 others. Okay. At a basketball game, adult tickets sold for $5 and children's tickets sold for $2. If 175 tickets were sold for a total of $686, how many of each type were sold? Okay, here we're going to have to get something we can substitute, so we're going to subtract the number of children's tickets from each, and we find that NA is equal to 175 minus NC. And this is what we can substitute in. Alright, 5. Now substitute in for this NA, 175 minus NC plus 2NC equals 686. And we put the 5 with the NA and the 2 with the NC in this equation because we have to attach value. We have a dollar value here, so we need one here and one here. Alright, so when I do my distributive property, I'm going to see that 5 times 175 is 875 minus 5NC plus 2NC equals 686. Combine these like terms and I have 875 minus 3NC equals 686. Alright, then I'm going to subtract 875 from both sides. And I will see that negative 3NC is equal to negative 189. Divide both sides by negative 3. And I will see that NC, or the number of children's tickets, was, 63. Alright, if there were 175 tickets sold, and 63 of those were children's tickets, 112 were adult tickets. Okay, real world application problems. So I will see you back next time for lesson 90.